Okay guys, here's our video on the Unit 6 final exam review. I'm just going to jump right in. This is a non-calculator section, so make sure you're not using a calculator. For number 1 and 2, we're trying to find the domain of the function. So the domain's asking what values of x can I plug in to get out a defined value. So the easiest thing to think about is what would make my function not be defined, or what might give me a problem. And so in this case, I can't divide by 0, so 2x minus 5 can't be 0. So I'm just going to essentially solve this. So that means that x can't be 5/2. So my domain is everything except for 5/2. So the only problem was dividing by 0. There was only one place that happened, so my domain is everything except for that value. For number 2, I have a square root. We don't have any denominator now, so I don't have to worry about dividing by 0, but I can't take the square root of a negative. So that means that the inside has to be greater than or equal to 0. Well, 0 is okay because the square root of 0 is 0, and I'm not dividing by it, so I'm going to do greater than or equal to 0. If I had an example like this, I will write on a sticky note. If instead of this problem, I instead had this, then I would have to say that 3 plus x has to be only greater than 0, because the inside of the radical has to be positive, but I also can't divide by 0. So that's why in this case I can't include 0, because the radical is in the denominator. But the problem I have, I can't include 0. So that's why I have a greater than or equal to 0. So let's solve this. I'm going to subtract 3 on both sides. So x has to be greater than or equal to -3. So that's a little hard to read, so let me rewrite that real fast. But I need to get rid of all of that. Okay, so if x is greater than or equal to -3, that means I want everything bigger than -3. I'm including the -3. I don't include infinity. Okay. So let's move on to zeros. There's asking us to solve, so I want to find the values of x that make this true. Remember, the easiest thing to do is always to start by getting 0 on one side. Okay. So the first thing I want to try is just see if I can factor this. It's always the easiest option, and it looks like I can, because I have two things that multiply to -5 but add to -4. So in this case, my zeros are 5 and -1. Now let's say I couldn't factor it. If you can't factor, then you're going to try the quadratic formula. So I'm just going to make a little note. Can't factor? Try the quadratic formula. Okay, so let's look at number 4 now. Number 4 is a little tricky. It's actually going to be a factoring problem, but you'll notice it's x to the 4th power. Now, if you're really not feeling comfortable with factoring, you can actually do your p's and q's and just start testing, but you're going to have to find 4 zeros. It's going to take a long time. So one thing that I've recommended that you guys do before is see if you can rewrite this, but anytime you see x squared, you're going to put a y. So if I rewrite this, this is the same thing as x squared squared minus 5x squared plus 4. So if I want to, I can rewrite this now. I'm saying anytime I see an x squared, I'm going to put a y. And this is easier to factor. I need two things that multiply to a +4 but add to a -5. So I'm going to do a -4 and a -1. So really what I have, remember, y was standing in the place for x squared. So I really have x squared minus 4 and x squared minus 1. Well, you could factor this into x plus 2 and x minus 2. This could be x plus 1 and x minus 1. So if you solve those, the zeros of this are plus or minus 2, and the zeros of this are plus or minus 1. If you need to actually factor that out to show the work, that's totally fine. Okay, number 5. For number 5, we have a cubic, so I can't use the quadratic formula. I'm going to have to just start guessing and checking. So I'm going to start by making my list of p's and q's. My p list is plus or minus 1 and plus or minus 5. So remember, p is all of the factors of this. Q is all the factors of the leading coefficient. So if I combine this list into my P over Q's, I have this divided by this divided by this, and that's actually all I have. So I haven't actually done this problem yet, so I'm going to start guessing and checking. I normally start with the ones. Okay, we can do this a couple ways. We can actually factor this one by grouping. So one option is at this point you can just start guessing and checking, and at least one of these four is going to be a real zero for you. But when I actually look at this, I notice that there's this pattern of 1, 1, 5, 5. So I can actually factor out, so if these first two terms, I can take out an x squared. And these second two terms, I can take out a minus 5. And you'll notice that when I do that, I have an x plus 1 in both places. So if I did do synthetic division, it turns out that my, my negative 1, so that actually was a good check if we had tested that first. So the 0 of this is going to be x equals negative 1. But for this one, I'm actually going to have to... Okay, so my answers are x equals plus or minus root 5, and x equals a minus 1. I'm going to pause this video and then I'll do the second part in a moment.